Let's now have one interesting application of polymorphism. Especially we want to see how to combine that together with the static type of our array elements and also the call by value concept that we spoke about earlier. And we're going to use one example called student management system here. And if you can recall the second design that we spoke about without using inheritance, we also got a student management system class. And remember what we had to do. We had to create one separate array for an array of resident students, another array for non-resident students. And whenever we want to maybe register a common course for all the students, we had to write duplicated loops. And that's definitely not a good idea. And now, since we got inheritance support, we will argue that we don't need to do that anymore. We only need a single array of student type over here. And that's something I will try to remark a little bit later to speak about in more detail. For now, let's now just build some foundation for understanding the idea. Okay, so that's the variable declaration. And let me now switch to my iPad, and then we'll talk about the more details of the design. Okay, over here. And you can already see the declaration here. We have student management system class, and this is the array attributes that we have, SS. And it's of type array of students over here. And here's a very important question to answer first. What is the static type of the different members, the different elements in the array? You can see SS is declared to be students array. So what will be the static type for SS index 0, SS index 1, all the way to the last element, which will be the length minus 1. So what should be the static type? It's a very simple question, yet important. Well, the answer should be whatever the member that's declared to be, which is over here. So this is the static type. So this is the static type of elements. So all the elements have the same static type. That's what they're declared to be when we first declare the array of array SS. All right. So that's a very important question to first answer. So that would be, the answer should be students. And we want to say, what will be the consequence of that? We learned about polymorphism. Given that the static type is actually students, right? Let's also get a hierarchy of the student class over here handy, right? You can see, let's say if the static type is actually students, right? Let me just write it down. So this is the static type of SS, array elements, each of the elements, right? So that's the static type. What can be the dynamic type that can actually be the member, right? What can we substitute it for? According to the rule of substitution, as long as the objects can fulfill the expectation of students, we will be okay. So the answer is it can either be itself or it can be its descendants, including resident students or non-resident students. So that means at the runtime, each member in the SS array can either be a student's object, can be a resident student's object, or it can be a non-resident student's object. So that means only a single array can really store all the mix of the student type. We don't need separate arrays. That's a very important observation to see. Okay, let me write it down. So the consequence is dynamic types of elements of the array can be descendants, all the descendants of students, which is a static type. Be very careful about the reasoning process we are doing here, right? Again, we are not teaching anything new. We're just trying to apply what you learned already. Okay, all the descendants of students, which is static type. All right. Having this in mind, let's now try to analyze the code a little bit more. And you can see here, we're also trying to use the integer counter for the array. So that's the programming pattern that we have been doing for so many weeks already. Let's now try to look at the three methods here, mutator method 1, 2, and 3. Let's look at one of them. The other two should be, you can also analyze yourself in a similar way. Let's take a look. Let's go very slowly. If you look at a parameter over here, let's say this is a parameter rs, sorry. So this is the parameter rs, first of all. So this is a parameter. And as soon as I talk about the difference between parameter and arguments, you will know that I should really talk about call by value. I will get there. Parameter. And this part here is a declared type of the parameter. So this is a static type of parameter. So this is the static type of parameter. I'll just say param for short. All right, and now I want you to look at this particular substitution or variable assignments over here. I want you to take a look at this. Is this valid? Right? That's basically this question over here, right? You can see this assignment here. What we're doing is SS at particular counter index, right? That's part of the programming pattern is assigned to RS. So we're asking about whether or not this will compile or whether or not it is valid, right? How do we answer that? Well, you can pause the video and think about what would be your detailed answer to this question, either valid or invalid. All right, assuming that you thought about it. So this is how I would analyze it. We want to see whether or not this substitution is actually valid or not, right? So this is a substitution. Substitution, valid or not. It will only be valid if the static type for RS can fulfill the expectation of the static type of this array indexing notation. Meaning that if the static type of RS is a descending class of the static type of this array indexing expression, in that case, it will be valid. Let's now take a look at exactly. You can see here RS, what's its static type? RS, the static type is declared to be resident students over here, as we said, right? Let's now highlight it. So this one here, you can see resident students over here. The static type will just be RS, right? Resident students. Static type is, I'll say RS for short, resident students. And what about the static type for the left-hand side? What about the static type for SS array at index C, right? That's something we just spoke about for question number 1. It should be students, right? Hopefully, so far, you're still following, right? Everything is simply just logical. Nothing is random. Okay, so this part over here, again, the reason that this part here should have the static, let me write it down. Static type should be students. And the reason that it should be static type student is because SS declared to be a student array. So that means every member is declared to be student type. So that's why it should be students at a particular index. Okay, so now we are basically asking, can resident students over here fulfill the expectation of students, which is over here? Of course, because resident students is a descending class of students. Okay, that's why it's valid. So this will be valid because static type of the right hand side, RS, is a descendant of the static type of the left hand side, SS at index C. Right? Of course, you can also put more detail about what exactly is the static type over here, and what exactly is the static type of this. Okay. Oh, actually, I forgot to say one more thing here. Over here, a descendant of the static type of. Okay, just to be complete, static type of SSC. All right, that's complete. Let's now look at one more question over here, right? And as an exercise, I want you to actually analyze, is this line valid? In a different method. Of course, you got to consider another parameter over here. And also, is this line valid over here? And you also got to consider a different parameter S over here. So that'll be the exercise for you, okay? So this one here, and also this one over here. So that will be your exercises. Valid or not? And justify it by some detailed answer. All right, the last question. Under what circumstances can the following method call be valid or it compile? Okay, let's talk about this particular method call. And we have the following assumption. SMS over here is a context objects. Let's assume that context objects of static type student management system. Okay, I'll just say SMS, student management system. That's what we assume. Otherwise, you cannot really call this @rs method, which is declared exactly over here. Let's assume that's the case, right? So now, in order for this particular method call to be valid, what should be the circumstance? Let me give you one hint, and then you can pause the video. The hints will be, think about the static type for the argument value O over here. Okay, let me write it down. So you can see the O here. This is the arguments. So this is the arguments, okay? And you want to think about its a static type. What should its static type be in order for this entire method call to be valid? All right, pause the video and think about it. Okay, assuming that you thought about it, in order to answer this question precisely, we have to consider callback value. Okay, once I show you the behind the scene action for callback value, everything will just boil down into the normal variable substitution. Let's see exactly how. Okay, now I want you to look at this part here is the arguments, right? As I said before the pause. And we are calling @rs. @rs is this method here, and then we got this particular parameter over here, right? So now we are trying to do call by value. So let me just try to do call by value over here, right? I'm trying to link all the way to over here, right? You can think this is the direction, right? So we got call by value. And what does call by value do for that particular method? It's going to assign the arguments to rs, right? As we said in the call by value lecture when we talk about aggregation and composition. Please review if you got any doubts. So call by value is going to say rs is assigned O over here. So rs is the parameter and O is the arguments. Now, how should this assignment or substitution be valid? Under what circumstances? So you can see this rs over here declared to be of type resident students over here, right? Over here, you can see this part over here. That's simply just resident students. So this part here, the static type is simply just resident students. And now, how can that, what should be the argument O's static type? Well, the answer should be, this will only be valid if the static type of O can fulfill the expectation for the static type of RS, which is resident students. And what class can really fulfill the expectation for resident students? The answer is any of its descendant classes. In this case, only resident students. All right. So the answer is should be the descendants. Let me just write a little bit thinner. The answer should be the descendants. Descendants of the resident student class over here, which is the static type of the RS over here. All right, so that's the answer. All right, guys, I think please review the answer to all these three questions very carefully. So these three questions are very important for you to understand. Whenever you're trying to make a method call over here, under what circumstances, in terms of the static type for the arguments, can the method call be valid? And we know that every time you try to make a method call, it can definitely be boiled down into the so-called call by value. In which case, you're really trying to do the following assignments to say parameter is assigned to the argument. So now we're just trying to make that context clear. So polymorphism will still work in that context. Okay, let me now just go back, right? I've said many details over here. You really want to review and also do the exercise and what I just assigned to you. All right, everything has been set over here, and we talk about here why this particular assignment is actually valid, and you really want to exercise as well why these two are also valid. I'll leave that to you. If you got any doubts, reach out to me. And whenever we are trying to make a method call, it's going to be a call by value behind the scene, which will be, for example, the parameter over here is assigned to the arguments O, which is here. Right? So when should that be valid? Okay, that's something we just said. All right, let's now do some exercises together. Let's say I got so many variables declared over here, and then we're gonna talk about whether or not they would be valid, right? When we want to make a method call. And you can see S1, S2, S3, RS, and also NRS. All these, I only highlighted their static types, meaning that when we wanted to determine if the method calls are actually valid in the compilation time, only the static types matter. And the dynamic type, in this case, as long as they are valid, for example, you can see students can fulfill the expectation for students. Resident students can also fulfill the expectation of student because this is a descending class of that, and etc. As long as this is okay, you don't need to worry about the dynamic type when you want to judge for compilation. Let's now switch to iPad, and let's now do the exercises together, right? Right, so now I already showed to you the relevant decoration over there. Okay, let's now try to look at the first few, one by one, and then try to see. The first one, is this valid? Okay, you can pause the video and think about it. Okay, this one here. All right, assuming that you thought about it, this one here, for the first one, let's now do a little bit more carefully. S1 over here is the arguments, and we are calling add rs. Add rs is actually over here. So the parameter that we are talking about is this guy here, right? So let's now try to do call by value over here. Okay, so call by value. So call by value is going to do rs is assigned to S1. Is this okay? Well, let's take a look at the static type. So now you can see that S1 has the static type students over here, right? You can see S1 is declared to be of type students. Static type is students. What about RS? RS declared to be of static type resident students. Static type is resident students. Now, can this substitution be valid? Can we substitute students for resident student? Apparently we cannot, because students cannot fulfill the expectation for resident students. Specifically, student is not a descending class of resident students, right? You can see students over here is not a descending class of resident students, apparently. So this is not valid. All right, I hope you're okay with this explanation. Why don't we do one more, and then I'll leave the rest as exercise for you. Let's do one more, okay? Let me choose a different one. So why don't I choose, let's say this one here. Let me choose the last one. So the one we just did is not valid, right? So the answer is not valid. Okay, let's do one more. Why don't we do the last one here? This one here. Is this valid or not valid? Pause the video and think about it. All right, assuming that you thought about it, so we are calling this method here add students, which is over here. Let's now highlight the parameter s and also the arguments nrs over here. Okay, and call by value is going to work like this, right? So let's now try to do this. Okay, so call by value is actually going to do parameter s is assigned to arguments nrs. Is this valid though? Let's see. So what we can do is let's look up the static type. nrs over here has the static type, right? nrs is here, that it was declared over here. Non-resident students, right? Non-resident students. And what about the left hand side, which is a parameter s? S is declared to be students. Static type is actually students. Now, is this substitution valid? It turns out it should be valid. Okay, let me just write it down first. It will be valid because NRS is a descending class of students over here. So this can fulfill the expectation for students. All right, so this is also valid. So that's why if I revalid it, it will be check. Right? I would say before you go back to the slides to actually see all the others, I will highly recommend you try to figure out all these, the answers, okay, to see whether or not they should be valid. And hopefully you can see from this, in order to really judge, again, let me just recap before I end the current video. Whenever you're asked to judge whether or not a particular method call is valid or not, you have to know two static types. One is about the static type of arguments. The other one is about the static type for the parameter. This static type must be able to fulfill the expectation of the static type of this, because behind the scene when we do call by value, we are really doing the parameter is assigned to arguments, right? That's the most important connection you have to make when you try to make the judgment. All right, now I will leave that to you to really do the exercise and review what's happening over here before we move on to the next topic.